All right, guys, we are getting ready for the Unit 3 test on patterns, factors, and binomials. And we've got to take a look at some of these study guide problems. First one is prime factorization of each monomial. So 150xy, we have to make a factor tree. And we're going to find out things that are factors of 150xy. So let's prime factor 150 first of all. It is 150 is 15 times 10. For example, could be any of those factors, 15 times 10. And then you got 3 and 5, and 3 is prime, 5 is prime. And 10 breaks down into 2 and 5, also which are prime, but we cannot forget to bring down our variables x and y as well. X and y, which we're going to deem prime as well. So we have 150 xy is equal to 2 times 3 times 5 times 5 times x times y. And its prime factorization. Those are all of the prime factors that make up 150xy. The next one, negative 68gh. Negative 68gh is the first factor is negative 1. We're going to say a negative 1 is prime for our prime factorization set. 68 is 2 times 34. Hopefully I won't make any silly mistakes here. 34 is 2 times 17. And once again, don't forget to bring down your variables g and h. So the prime factorization of negative 68gh is negative 1 times 2 times 2 times 17 times g times h. Go ahead and highlight those. Greatest common factor of 36x and 64. It helps to really know what the heck the greatest common factor is between two numbers. That is the biggest number that will divide both numbers evenly. So you have to think about 36x and 64. What is the biggest thing that goes into both of those numbers? You could probably think of some things. Do they share any variables? That's the other thing that you have to think of. In this case, you can see this one has an x, this one doesn't. They don't share any variables. So 36x and 64. You think about the numbers that will go into 36x and 64. I can only think of a couple, mainly 1, 2, and 4, in which case 4 would be the greatest common factor of these particular things. But there's another way. You can also use the prime factorization method. Prime factorization method, what we're going to do is we're going to break down both monomials into their prime factorizations. You have to do a tree if necessary. So 36x is 2 times 2 times 3 times 3. Let's pretend that I made this beautiful factor tree to find that, and I just didn't do it in my head. 64 is 2 to the 6th power. So I'm going to write out all 6 of those 2 factors. And then you get to circle anything that matches. Circling anything that matches. And they share one prime factor of 2 and another prime factor of 2. So the greatest common factor is going to be the product of those 2 factors. So 2 times 2 is 4. The greatest common factor, like we said when we did it mentally, is 4. Least common multiple is the smallest thing that both of these monomials are going to go into, the smallest thing that they both go into. So think about 18 and 30. What are the multiples of 18 and the multiples of 30 that will be shared by both of them? So you might be able to think about the multiples of 30, 60, 90, 120, etc. So you could do that and then think about the A's, the variables, okay? What we're going to do for the least common multiple on those is we're going to take the highest exponential value of each factor that we see. So in this case, would I take a or a squared? Well, the multiple, the smallest multiple that a and a squared would share would be a squared. But once again, there's a prime factorization method. Let's do it. It's 30 a to the second and 18a. The prime factors of 18a are 2 times 3 squared times a. 30a squared is going to be 5 times 6. Well, 5 times 6 is 2 times 3. 5 is prime itself times a squared. Now, the prime factor method here, we're not making matches anymore. We're taking one of every prime factor we see. If it is there twice, you take the higher exponential value. I'm going to take a squared instead of the a. Take a 5. 2 times 5 is 10. 3 squared is 9. The LCM is going to be 90. And don't forget the variables, a squared.